So on the left, I have a Ponceletian family of triangles, ABC, blue, right? And these triangles are inscribed in a circle and circumscribe a generic caustic specified in the simulation by the position of F1 and F2. So there's a four-dimensional family of caustics that will admit a family of Ponceletian triangles here. Okay, so I can flexibly move its caustic. On the right, I have the projective image. Let me actually bring this close here. I have the projective image A prime, B prime, C prime of ABC, and specified under some 3x3 fixed projective matrix M. It doesn't matter what these entries are. I just want to make sure that this is not an affinity by keeping these bottom two entries here non-zero. Okay, very good. Now I'm also reporting over here the ratio of semi-axes A out over B out of the projective image of the circle, which is basically the circumscribing conic to A prime, B prime, C prime. Now, this conic here has an aspect ratio 1.4, or the ratio of its axes, and also an orientation of the x-axis, say, with respect to the horizontal, which is being shown here as 48 degrees. Okay, now, yes, so let me go ahead and move this guy here just a little bit like so, okay? Now, what I'm also showing is x2 of A prime, B prime, C prime, which moves as expected along a conic, in this case, a small ellipse, okay? And I'm also reporting down here the product of its axes, the ratio of its semi-axes of this green locus here. You can see that 1.4002 is the same as the ratio of semi-axis of the outer conic, and the angle that its major sub-axis, major axis makes with the horizontal, which is 48.38 degree in this case, and it copies that of the outer conic. So it's true that this is going to remain the case for any chosen axis. You're getting little 180 degree jumps here, but you can see here that as I move my my caustic, okay, the aspect ratio and the orientation of my x2 locus, and let's make this x2 locus be a bit more visible by perhaps choosing a better, let's see here, how do I do this? Like that, okay? Choosing, make it more flashy. The important thing here is that once you choose a particular projectivity, you get this outer conic, which is basically the projective image of that. That outer conic is going to have a ratio of axes and, say, a major axis orientation, which will be copied, and this is the new observation, by the locus of the barycenter of the A prime, B prime, C prime family. Okay, for any choice of the caustic. So how cool is that? Okay, now what we found out as well is that, so one thing that you can say here is that the aspect ratio, eccentricity, and the orientation of the locus of x2 prime does not depend on the caustic. It only depends on the shape of the outer conic. If you want to forget about the left-hand side system, right? This is just a generic Ponceletian family of triangles. The locus of x2 prime, not only is it a conic, its aspect ratio and orientation only depend and copy those of the conic that circumscribes them. What we found out is the same is true for the orthocenter, and we don't know why. So let's see if I can get this thing to display the characteristics I want. Yes, so you can see here the orthocenter has like this 90 degree, look at the foci here, so turned 90 degrees. So I'm also reporting here the orientation of, say, this axis here with respect to the horizontal, and I'm adding 90 degrees here just to make sure that we get the same result. And you can see here that once again, for any given caustic, okay, that we choose, the locus of x4 is also copying the aspect ratio and the orientation of the outer conic plus 90 degrees because it's rotated. So you can see here that 1.479 is copied here. It's not conserving area, right, as for different types of choices of caustic. It's not conserving area. but it is reproducing the aspect ratio and orientation of the outer conic of the Ponceletian family. So we're getting this phenomenon for both x2 and x4. So one way to say this is that for generic family of Poncelet triangles interscribed between any two ellipses, okay, the aspect ratio and the orientation of the x2 and x4 loci is independent of the caustic. It only depends and reproduces those two quantities of the outer conic. See you in the next video.